This sequence, a crude, monochromatic wireframe sketch, builds directly into a fully lit, photorealistic scene in a matter of seconds. To go from raw text to a final broadcast, you need a specific software ecosystem working in tandem. That pipeline relies on three main tools: Google Flow, Gemini, and Notebook LM. Operating these tools requires strict project management. You have to define your constraints early and rely on an iterative, step-by-step versioning process to keep the models on track. If you skip that planning phase and rely on loose instructions, the models will struggle to interpret your goals. You will burn through generation credits and end up with unpredictable visual anomalies instead of usable footage. Step 1 starts with what we call ingredients. Instead of guessing, you upload your raw text, historical references, and field research directly into Flow or Notebook LM. This builds a dedicated, custom knowledge base for your project. Here in the Nano Banana 2 interface, we convert that raw knowledge into a highly detailed natural language prompt. Notice how the text avoids vague terminology and explicitly defines the lighting setup and the character's clothing, giving the AI exact parameters to match the loaded image thumbnails. Once your ingredients are set, you can execute the frames-to-video method. This takes a basic sketch that you provide and allows the AI to render it into a photorealistic starting frame. By supplying explicit reference ingredients and generating a clear starting frame, you eliminate the blank page problem entirely. The math of the model is now locked directly onto your specific vision. Looking at this timeline in Google Flow Scene Builder, you can see exactly how those loose ingredients are organized into a cohesive chronological storyline. To maintain continuity from one cut to next, you will use the Jump To and Extend features. By pairing these with specific @tags, you ensure that your characters and objects remain consistent across multiple shots. As you built this sequence, you have to manage your generation credits carefully. There is a strict operational trade-off between the Veo 3.1 fast model, which is highly efficient, and the Veo 3.1 quality model, which demands significantly more computing power. This clip shows what happens when you let the fast model run unsupervised. The sports car travels down the road, but suddenly slides entirely sideways through the curve. It is a complete failure of physical momentum. To protect your narrative and your credit balance, you must enforce an iterative versioning process. Setting explicit stopping points for qualitative review catches these physical errors before they compound into your final edit. For complex interactions, like this highly reflective glass orb rolling across an uneven surface, you run advanced prompt chains through Gemini Omni. The model calculates the complex physics and applies visual effects sequentially without breaking continuity. Small 1080p video files pass through a central upscaling node, emerging as large 4K blocks. These lock into place as our parallel audio pipeline comes in below. Flow music outputs sync up in environments like Ableton to create one unified master file. Pairing 4K visual upscaling with strict 32-bit audio mastering provides the exact technical fidelity required for professional studio deployment. With the visual and audio tracks mastered, the final assembly stage takes place offline in native tools like iMovie, or organized centrally via Google Drive. Next, you use mobile applications to slice that long-form master file into optimized high-retention vertical assets. Those vertical assets are then distributed to your mandatory global syndication targets: YouTube, X, TikTok, and Instagram. By mastering this Google Studio AI framework, you bypass the traditional limitations of budget, crew, and location. Your prompt engineering is the only remaining boundary to your global reach.